Hello everyone. So in this project, we are going to discuss Pokemon analysis. We have taken a data set of various Pokemons in which the name of Pokemon is given, his type, uh, attacking power, defense power, and everything is given. Color is given, gender is given, and its group is given, height and weight is given, body style is given, and there are many attributes. So let's discuss this. First of all, we are importing various libraries like Pandas, NumPy, Seaborn, and Matplotlib. After that, we are reading the data set that you can see over here, using the read CSV function. After that, we are using the shape attribute and we are printing the number of rows and columns in the data frame. Next, in the third cell, we have used the dtypes attribute, which presents the data type of every column that you can see number is integer type, HP is integer type, and so on. Object is the string actually. Next, we have used isNull function followed by sum. So this prints the number of null values in each of the column. So we can say that a egg group 2 has 530 null values in this. Next, we have used describe function, which mainly prints the statistical parameters of all the numeric columns of the data frame. So mean, standard deviation, minimum, quartile ranges, maximum are displayed. Next, we have used heat map function of Seaborn library. SNS stands for Seaborn. We are printing the correlation matrix using the color scheme YLG and BU. So this is it. Next, we are plotting the box plot. So box plot is mainly used to show the number of outliers in the column. So we have plotted the box plot for every numerical column of our data frame. We have used box plot function of Seaborn's library for this. Next, we have box plot for attack column. Then we have it for defense column. Then we have for special attack column, we have for special defense column. These dots mainly represent the outliers in the data. We have plotted the box plot for speed column. We have plotted for generation column. Then we have plotted for height column. You can see that there are many outliers in the height column. We have plotted it for weight column as well. We have plotted it for the catch rate. That is the last box plot. Then we have plotted the line plots. That is a line graph in Seaborn. We have used line plot function. We are passing y-axis, x-axis, and the data is data frame mainly. So this is it. On the y-axis, we are having the weight, and on x-axis, we are having the body style. So this is the line plot, and this is the figure size that we have defined. Next, we have plotted a collective box plot that shows all the numeric columns in one single box plot instead of plotting it into the multiple subplots that we have done above. Next, we have plotted a count plot mainly in which we have used body style on the x-axis and has gender column as the distribution parameter that is that you can see, right? So for example, let's consider this one that two wings. You can see my cursor. The body type two wings. In the body type two wings, you can see that orange bar stands for true. So this much number of Pokemons under two wings body type were having a gender, and this much the blue bar actually this number does not have a gender under the two wings body type. Next, we have count plot for isLegendary column. We have used count plot function again for of the Seaborn's library. SNS stands for Seaborn. So maximum of the Pokemons were not legendary, that you can see that height of bar for the false is greater than true. Next is the machine learning. models. So we are dropping the irrelevant columns actually, first of all, which are not required for our analysis. So number, name, type 1, type 2, color, generation, male, age group 1, 2, then evaluation, body style. These columns we are dropping because we don't need them in our analysis anymore. Next, we are using info function. So we are printing the null count and the data type of the remaining columns of the data frame, that remaining columns after the dropping that we have done this in this step, right? So let us start with our first machine learning model, that is a random forest classifier. We are using sklearn library for the random forest classifier that we can see. We are importing the random forest classifier. We are importing test train split. We are importing classification matrix, confusion matrix, accuracy score, and other parameters. So first of all, let us consider a target variable. So for example, in this use case, we have considered isLegendary as our target variable. So we are storing this target variable in the Y variable, and the columns other than our target variable that we are storing in the X variable. Then we are using train test split function, and we are passing 0.20 as the parameter in that, which means that 80% data will be used to train the machine learning model, and 20% of the data will be used to test the machine learning model that will be used to calculate the accuracy in the later stage. So this function returns 4 parameters: X train, X test, Y train, Y test. After that, we are using random forest classifier function, and we are passing estimators as 600. So we are using 600 estimators. We are storing the instance of the variable of the model in RFC variable. So we are fitting our model using the train data, that is the 80% of the data. And after fitting, we are storing this particular thing in the model variable. So when we are testing our data, when we are testing our data set using the test data, we can see that we are getting an accuracy of 99.3%. So we can say that our model is, very, very accurate and very effective to use because it is able to predict 99.31% values accurately. So that's all. As far as accuracy is concerned, we have used accuracy score function that we have imported from the Seaborns library that you can see over here, right? So that's it. ROC score we have imported over here from the sklearn library itself. Next, we are plotting the confusion matrix for the above prediction. So we are importing classification report from sklearn.matrices, and again we are passing the test data to predict the accuracy, and we are storing it. We have passed the parameters in the confusion matrix function, and then we have defined the figure size of the confusion matrix. We have used C1 library and the function heat map, which is defined in the Seaborn itself. This function is mainly used to show the graphs like this, or the heat map that we have discussed above also. In this case, we can see that there are 136 false negative, and there is only one false positive value. This is the 120, 100, 80, 60, 40, 20, 0. This is the color scheme. Next, we are printing the confusion matrix in the simpler words without any generation of figure, right? All these figures are capable of being saved in PNG format, JPG format, or any format that you want. Next, we have a decision tree. In this particular machine learning model, we have used isLegendary function, isLegendary column as the target variable, and we have used test train split function to split the data into 75-25 ratio. when we are calculating the accuracy, it comes out to be 97.24%. So which is a bit less than the random forest classifier, but our accuracy score is pretty much good. Next, we have plotted the confusion matrix using the same steps that we have followed in the random forest classifier. We have used the color scheme as green this time instead of blue. So let's see the confusion matrix. We have 163 false negatives and 13 true positive values. And this is the color scheme that we can see. That's all about Pokemon analysis. We have discussed the EDA, that is the exploratory data analysis. We have discussed the data cleaning. We have discussed machine learning models. So that's all about today's video. Thank you.